Assalamu alaikum friends. Today we are going to study about binary search tree, and we will do an example to understand that how we do insertion and deletion in binary search tree. So we are given a question in the exam that we have to draw a binary search tree by inserting the following numbers from left to right. So these are the numbers that are given to us and we have to insert them. We have to start from left and we have to go towards the right, and we have to insert them one by one into this binary search tree. Okay, so the conditions whenever we are dealing with binary search tree is that number one is that the binary tree is having at most two children. So a binary tree can have zero children, it can have one child, and it can have two childs, but it cannot have more than two children. So this is the first and foremost condition whenever you are making a binary tree. And the second condition is that in a binary tree, the left subtree value is always less than the node that you are considering. Similarly, the right subtree value is always larger than the node that you are considering. I will put more light onto this second condition when I am going to solve this example. Okay, so now let's start the solution. So first of all, we are starting from the left hand side, so we will put this 11 on the top as the root node. Okay, now I'm going to insert the 6. So 6 is 6 greater than 11, or is 6 smaller than 11? So of course 6 is smaller than 11. It means that it will go as my left subtree. So now you understand this condition, that 6 is smaller than this node, so I put it onto the left subtree. I do not put it onto the right subtree. Okay, so now 8 is 8 smaller than 11? Yes, it is smaller than 11, so it should go onto the left subtree. But 8 is larger than 6, so it should go onto the right subtree of the left subtree. So here you go, you come onto the, first of all you come onto the left hand side, and then onto the left hand side of 11 you connect it onto the right hand side of 6, because 6 is because 8 is larger than 6, so you put it on right hand side of the this subtree. Okay, now 19. First of all, compare with the first number. Is 19 larger than 11? Yes, it is larger than 11. So as per the second condition, it right subtree values are always larger than your node, so 19 should go on to the right hand side. Okay, it will come on to the right hand side of 11. Okay, now come on to the node on the value 4. Is 4 smaller than 11? Yes, it is smaller than 11. It is smaller than 6. It is smaller than 8, and it is also smaller than 19, so it will go on the extreme left hand side. So it will come on the left hand side of 11, and it will come on the left hand side of 6 as well. Okay, now 10. Is 10 smaller than 11? Yes, it is smaller than 11, so it will go on to the left subtree. But 10 is not smaller than 6. 10 is larger than 6, so when we go on to the left subtree, then 10 will become the right element of the left subtree. So here you can see that you already had a 4 here, so you will start trickling down from the top. From 11 you will come on to left subtree side, and you had 6, and you had 8, so you will connect this 10 on the right hand side of 8, because 10 is larger than 6. 10 is larger than 8, so it will come on the right of all of them. It will become the right branch of the left subtree of 11. Okay, why you went on to the left side? Because this 10 was smaller than 11. Now why you came on to the right side? Because this 10 is larger than 6, and this 10 is even larger than 8. Okay, so now come on to 5. 5 is smaller than 11, so it will go on to the left subtree, and 5 is even smaller than 6, smaller than 8, 19. So it will till here it will be on the left hand side, but it is larger than 4. So when it reaches 4, it will become the right hand side partner. So from 11 you will go on to the left hand side tree, and from 6 again you will go down and you will be going on to the left hand side. But now after 4 you will no more go towards the uh, left hand side, you will simply come here towards, you will make it the right partner. Here I have written that 6 is smaller than 8, but 6 is smaller than 7. Okay, forget it. Simply you have to connect it on to the as the right member of 4. Why right member of 4? Because you see that 5 is larger than 4, so it will not be connected here, it is smaller than 4. But why you placed it as the left subgraph? Because 5 is smaller than 6, and 5 is smaller than 11 as well. Some students will be asking that why we are not connecting it as the member of this 8. So the answer is that when you are on this level, you are coming down from 6 and you know that there is you are coming down from 6 and you know that your 5 is smaller than 6, so you will travel towards the left hand side, you will not travel towards the right hand side. And when you are traveling from 4, then you see that 5 is larger than 4, so you will travel on to the right hand side. So whenever you are on the node, you make your decision, and if the next number is larger than the node, then you start traveling towards the right hand side, and if the number is smaller than that node, so this principle is very important. Okay, so now 17 is larger than 11, so we will come on to this side. But 17 is smaller than 19, so you will not go to right hand side, you will go to left hand side and you put 17 over here. 43 is larger than 11, so you will go on to this hand side, and 14 is again larger than 19, so you will again go on to right hand side and put 43 here. 49, so you will again follow this route and come here. And for 31 you will start trickling down from 11, it is larger, so you come here, you come here. But now here 31 is smaller than 43, so you will not go to this side, you will come to the left hand side. So this is how all your values are inserted into the binary search tree. In the next video we will find out that how do we do insertion, so how do we do deletion. So by now I hope you are clear that whenever you are given with the values and you have to insert the numbers from left to right, then you have to consider these two principles, that for every binary tree there can be only 2 children, there cannot be more than 1 children to any node. So you see this node has 2 children, even this node has 2 children, this node has 2 children. Similarly, this node is having this child and this child, so only 2 children are there for each node. And then the value which is smaller than the node, it goes on to the left side, and the value that is larger than the node, it goes to the right side. So with this I hope you understand the insertion mechanism. In the next video we are going to study about the deletion mechanism. Thank you very much. Do like the video, do subscribe to the channel, write down your questions in the comments. Thank you. Allah Hafiz.